This is the Algebra 1 Performance Final review. The Performance Final itself will be posted on all the Algebra 1 e-classes on Wednesday, April 29th. I wanted to show, to begin with, for the Performance Final, as usual, you'll only choose to do a certain number of the problems. In this case, we have 3, but you're only going to be choosing 2 of them. But I want to emphasize that this page, this is one problem, okay? Part A and Part B make up one problem. The same on the second page. This is for Unit 5, and there's a Part A and a Part B. This is all one problem. And then the same for the questions for Unit 6. Part A and Part B make up one problem. So you're going to need to choose 2 of those to do on the Performance Final. And these problems on the review are very similar to the ones that you're actually going to see on the Performance Final. So I'm going to go through each individual part, but remember that you have to do Part A and Part B of the problem that you choose. All right, so this one says, Cinderella currently does chores for 120 minutes per day. Her evil stepmother wants her to do chores for 200 minutes each day. Each week, her stepmother is increasing her number of minutes by 10%. Her fairy godmother suggested that Cinderella negotiate, that just means talk over what the plan is, with her stepmother for an increase of only 5% per week. So the first part asks us to write an exponential function to represent how long Cinderella will do chores after X number of weeks if she goes along with her stepmother and does not take her fairy godmother's advice. So in other words, if she has the 10% increase. Well, remember, this is how we write exponential functions. Y equals A. A is initial value. 1 plus or minus R. R was the rate, the growth or decay rate. Then to the X power. And in this case, X represents the number of weeks. So for number 1, to write this equation, it's going to look like this. Y equals, our initial value is 120, because that's how many minutes per day she does chores right now. That's our initial value. Okay? Then 1, and we're going to use plus here because in each case it's increasing. Whatever the rate is, it's increasing. So we're going to use exponential growth. We're going to use a plus there. And remember the little trick of if it's increasing by 10%, I have to put 0.10 here. You're dividing that 10% by 100, or you can think of it as moving the decimal point to the left 2 times. 1, 2. And that gives you 0.10, and then that's to the X power. All right, that's our equation for number 1. Then for number 2, it asks us to do the same thing if she chooses to take her fairy godmother's advice and only have an increase of 5% per week. So the equation is going to look exactly the same, except for we're going to have 0.05 here. And be very careful because it's not 0.5. 0.5 would be 50%. 0.05 is 5%. All right, so that's the answer to number 2. Then for number 3, it says after 4 weeks. Remember, weeks are the X value in the equation. How long will she be doing chores with each option? So all we have to do then for number 3, I'll write it down here, is plug in the 4 each time there's an X. So Y equals 120. Oops. And then I'm going to combine the 1 and the 0.10 and just make it 1.10 to the X power. In this case, X will be 4. All right, when we work that out, you find that that's 176 minutes. Okay, and then with the other option, Y equals 120 times 1.05 to the 4th power. And if we work that out, we get 146 minutes. All right. Then the second part of the question says, will either option meet her stepmother's requirement? Well, her stepmother's requirement was this 200 minutes each day. Well, neither one of these options here are 200 minutes. So the answer to that is no, it does not meet her stepmother's requirements. Okay, 4 asks us, after 6 weeks, how long will she be doing chores with each option? Okay, y equals 120 times 1.10 to the 6th power this time. And the other equation, 1.05 to the 6th power. Remember how to put these in the calculator. You use that little, usually on most calculators, it's that little symbol like this to do an exponent. It may differ from calculator to calculator, but that's very common. Okay, so when you work this one out, you get 213 minutes. When you work this one out, you get 161 minutes. And then it says on number 5, should she follow her fairy godmother's advice? Well, this is the option that her fairy godmother gave her. So I guess it depends. I'm going to say yes, she should follow it, because with her fairy godmother's advice, she does not have to work as long. Okay, here's the B part of the first question, and here we have a graph. And remember, the first thing you want to look at when we have a graph is what does the x-axis represent and what does the y-axis represent. The x is the end of the round, in other words, round 1, round 2, round 3, round 4, and then the y-axis is the teams remaining. We're talking about a tournament where teams play against each other and those that lose are eliminated. So the first question says, does this graph represent exponential growth or decay? Well, remember, we read a graph from left to right, just like we read a sentence, and we see that this graph starts, this curve starts way up here. It's around 65, and then it's quickly decreasing. So, of course, it's going to be decay. Okay, the second question says, approximately how many teams were involved at the start of the tournament? That's asking about initial value. And initial value is just where the curve crosses the y-axis. Well, we already said it's right up here, around 65. So there are about 65 teams when we started out this tournament. Then the third question, after how many rounds do you have your winner? When you have a winner, that means you only have one team left. So it's hard to see exact numbers on this graph, but I'm going to say that right here, it looks like if we go over to the x-axis, maybe we have 2 teams left. So after 5 rounds, and those 2 teams have played against each other, then we're going to have our winner. So after 5 rounds, that's when we only have one team left. And we can explain that by saying at 5 rounds, we have 2 teams. Okay? All right, moving on to the second question. This is part A of the second question. A new game show has participants choose their cash prizes based on simple functions. After winning the game show, you get to choose from 3 prize options, and here they are, option A, B, or C. For each function, X represents the number of days you are able to collect the prize. So the first question asks, which type of function, linear, quadratic, and exponential, do each of the prize options represent? Remember, we talked about all 3 of these functions. Well, it looks like the first option is exponential. And we can tell because there's an x there as the exponent. That's how we know it's exponential. The second one is linear. There is no exponent, or we could say the exponent is 1, so it's just a linear equation. And then in this last example, the exponent is 2. And remember, that means that it's quadratic or a parabola. Remember all that time we spent on parabolas? They all had an exponent of 2. All right, so the second question asks, if you are only able to collect your prize for 7 days, in other words, x equals 7, which prize option will pay the most and how much will you collect? So all we have to do is plug the 7 into the 3 equations, and they've given us the equations, so we don't even have to do that work. So for this one, for 7 days, a of 7, this is problem number 2, a of 7, when we put the 7 in right here as our exponent, we get $32,768. When we put 7 in for x in the b equation, we get 1,200 times 7, which is going to equal 8,400. And then when we put 7 into our third equation, we get 150 times 7 squared, and that's going to pay us $7,350. So in this case, the prize option that will be the most will be the exponential function, which is usually the case. And it pays us $32,768. All right, for number 3, we're going to plug the numbers in again, but this time it's asking us about 14 days. So A of 14, B of 14, and C of 14. This is where you put the 14, where the X is. Wherever there's an X, that's where the 14 goes. All right, and then here, for our 3 values, we're going to get a huge number here. If I can fit it in here. 5, 3, 6, 8, 7, 0, 9, 1, 2. A lot of money. Here we get 16,800. And then here we get 29,400. All right, so in this case, again, it's going to be the exponential option that's going to pay the most. And it's this big number here. And you guys know how to put this in your calculator. You can get these answers easily. All right, number 4 asks about 28 days. So we're putting 28. This is going to be a huge number this time. 1,200 times 28 and 150 times 28 squared. Make sure you put the 28 where it goes. Okay, for this first one, you get 1.4 times 10 to the 17th power. Now, this is where in your calculator you get that little EE symbol, and then it will have a 17 there. That's what that means. It's scientific notation. 1.4 times, basically a 1 with 17 zeros, so don't let that throw you off. All right, and then the second linear function is going to give you 33,600, and then the third 117,600. So again, exponential is going to give you the maximum amount, and then the amount is 1.4 times 10 to the 17th power. In part B of question 2, we're given a graph. We have 3 guys here, Tom, Sean, and Billy, and they tracked their productivity over an 8-hour workday. We don't know exactly what their productivity is, but maybe they're making circuit boards, and this is how many circuit boards they make, whatever, but over an 8-hour workday. So that the x-axis is time, there's the 8 hours, and then the y-axis is productivity. Okay? 4 students were asked to analyze the graph below: Robert, Chris, Scarlett, and Mark. Which student's observation is incorrect or not correct? Read the question carefully because you want to make sure you're answering it according to what's being asked. All right, so we got Tom, we got Sean, we got Billy. The first statement says Tom's productivity rate can be represented as a quadratic function. Well, that's Tom right here, and that looks like a parabola. So Robert, I would say, is correct. Chris says Tom's maximum rate is 62 after 4 hours. Well, if we find the 4-hour mark and we go up to his curve, we find that over here, it's about 62, right? So Chris is correct. Scarlett says Billy's productivity rate will eventually be better than Sean's if tracking continues because his function is increasing exponentially. Well, here's Billy. It doesn't show where his function goes, but we know that exponential growth always exceeds linear and quadratic. So we got to assume that Mark is wrong, but let's take a look at his statement. Sean has the best productivity rate throughout the day. Well, this is Sean. He's linear, right? Well, he does have the best productivity rate for a little while right here, but eventually Billy is going to exceed his productivity rate. So Mark is not wrong. I mean, not right. He is saying that Sean always has the best productivity rate. So the answer to this one would be Mark. Okay, so this is part A of the third question. If you choose question 3, you need to do this part and part B as well. This is a question about box and whisker plots. You guys did a lot of these on the Go Formative assignments. We have 2 salespeople, Angela and Carl, and we're comparing their number of sales. So we're going to write this down here because we want to know what our number line is representing, number of sales down here. All right, we're going to analyze these box and whisker plots. The first question asks what percent of Angela's sales were approximately 20 or less. So if we find 20 here, we go up to Angela's box. It's about where her Q1 is. Not quite. Miss Holt's line is not exactly straight, but it's around where her Q1 is. Well, this is where you have to remember that in a box and whisker plot, each section of the data is 25% of the data falls in each section. So from the minimum to Q1, there's 25%. From Q1 to the median, from the median to Q3, and from Q3 to the maximum, there's 25% each time. So if we want to know how much data is down here below 20, 25%. It's as easy as that. Okay, the second question asks, what is the approximate third quartile for Carl's sales? Well, we're looking for Q3, so we have minimum, Q1, median, Q3, and maximum. If we go down here, Q3 looks like it's maybe about 47, I'm going to guess. All right, it's based on the box and whisker plots above. Is it more common for Angela or Carl to have 30 sales in a day? And explain. For this question, I'm going to change the wording a little bit. Is it more common for Angela or Carl to have more than 30 sales? And I think that's more how it's asked on the final itself. Because if you look up here at the data, they both have a median of around 30. Angela's is a little less than 30. Carl's is a little more. But as you can see, Carl has a lot more data above the 30 mark. Even his median is above the 30 mark. So I'm going to say Carl would be the answer to that question. On number 4, what is the range of sales? Range of sales, it says in the middle 50%. Now, the way you guys are used to seeing this is IQR. It's asking about the interquartile range, Carl's interquartile range. Well, IQR is Q3 minus Q1. In this case, Carl's Q3, we said, was around 47. His Q1, let's see, looks like it's maybe around 16. So let's say his interquartile range is 31. So that's the answer to number 4. On number 5, it asks which plot has a skewed distribution. Remember, skewed means moved to the left or moved to the right, but it's kind of the opposite of what you would think. So if we're looking for skew. If we look at Angela's box here, we see that her median is right here. She has a lot of data to the right. Whereas Carl's data, his median is right here. Looks like he has about the same to the left and to the right. So I'm going to say that Angela's data is skewed. And I'm going to say that it's skewed right. And that's because there's a lot of data over here to the right of her median, so it's skewed right. Then part B of the third question, two-way tables. You guys are experts on these two-way tables now. In this particular two-way table, we're comparing how many times people eat fast food, as opposed to whether they drive to work or use public transportation. That means like the MARTA or a bus, something like that. So it says she wants to see if there's a relationship between these two, this girl Erica. So she conducted a survey where they answered how often they eat fast food and whether they drive to work or use public transportation. And here's some of the numbers already filled in. We have the 35, the 24, the 76, and the 102. We have to fill in the rest of them. So you guys know how to do this. We say for this number here, it's going to be 76 minus 35, which is going to give us 41. In this box, we're going to add the 41 and the 24. 41 plus 24. So that gives us 65. For this box, we're going to add the 102 and the 65. That gives us our total amount of people that she surveyed, 167. So then for this box, we can say, see, it's kind of like a puzzle, 167 minus 76, because these have to add up as well. So for that, we get 91. And then for our last box here, 91 minus 24. That's how it has to work, 67. So those are our blanks in the two-way table filled out. Okay, the question for 7 says, what percent of the people who drive to work eat fast food 0 to 2 times per week? What percent of the people who drive to work? So we have to be careful. We're not taking the percentage from the total amount of people. We're taking the percent of the people from the people who drive to work. Well, that total was 102. So 102 is going to be on the bottom of our fraction, the denominator. What percent of those people eat fast food 0 to 2 times per week? Well, that's this category here. So the number we're looking for is 35. So it's 35 over 102. So that's going to be 34%. Then the last question says, does there seem to be a correlation? And this is that last section that we did. Some of you did really well. Some of you struggled a little bit. But it says between how often someone eats fast food in a week and how the person gets to work each day. And they ask us to explain our reasoning. Well, what we did to figure this out is look at relative frequencies. And I don't want to confuse you by writing a whole lot of stuff in the chart. But basically, if you figure out the relative frequencies, for example, I'll just make the center of the two-way table here. You're dividing each number by the total number of people that we surveyed for this. So here you have 41 over 167, 67 over 167, and 24 over 167. So that means that your relative frequencies are going to be 21%, 25%, 40%, and 14%. Well, if you notice, it looks like a lot more people, 40%, who drive to work eat a lot of fast food. They eat fast food 3 or more times per week. So because there is a big difference in the percentages, in the relative frequencies, then we can assume that there is an association. Now, they use the word correlation here. It's the same thing. There is an association. There is a correlation. Same thing. And it makes sense, right? Because if you drive to work, you're probably going to go through the drive-thru more than other people. All right? So watch this video as many times as you want to. I know it's a little long. I'm sorry about that, but hopefully this will help with your performance final on Wednesday.